Okay, good morning. Now yesterday I have revised minimum number of teeth, then hunting tooth, then I have covered force analysis. Then last point that is beam strength of the spur gear tooth, that is nothing but Levy's equation we have seen. I think all of you have understood it or not. Revision, whatever I have taken. Now today we'll see next part. Some theory I will take, and since this is 2 hours lecture, we will take problems also. Now I can assume that you have brought your calculators, then notebook should be there, so that you have to write down the problem, you have to solve the problem with me. Those students who are online, they must be with their notebook, pen and calculator with them. Then and then it is possible to solve the problem. Sometimes you write down this theory also. Therefore, now we'll start. Next point is permissible bending stress. Now, why we have to take permissible bending stress? We are knowing that in case of Levy's equation, that is while deriving the Levy's equation, what we have derived? SB is equal to md sigma b into y. Therefore, that SB is nothing but tangential force, PT. Earlier, what we have derived that equation? We have derived the equation like this. We have derived the equation PT is equal to mb sigma b into y. PT means tangential force. Then we have considered that beam strength, it is nothing but what? Maximum tangential force that gear tooth can transmit without bending failure. Without bending failure. That's why we have considered that PT is equal to SB. SB is nothing but beam strength. Strength means force. Always remember, strength means what? Force or thrust. These are synonyms. Synonyms means samanarthi shabda Marathi मध्ये. You must know the synonyms also. Therefore, this SB is equal to mb sigma b into y. Now, in this equation, this m is nothing but module, b is nothing but beam strength, sigma b is nothing but permissible bending stress, and y is nothing but Levy's form factor. Slide is visible. Huh? Ata? Not visual? Okay. Now, therefore, we have seen that SB is equal to mb sigma b into y. Now, this SB is nothing but beam strength, m is nothing but module, b, this face width, sigma b bending stress, y, Levy's form factor. हॅलो सर, माझं लेक्चर चालू आहे. हा जावा तुम्ही, मी थोड्या वेळाने फोन करून सांगतो तुम्हाला. एक 12 पर्यंत लेक्चर आहे. काय दुपारी 3 नंतर गेलं तर चालतंय, काय अडचण नाही. आता 10 वाजता उघडते की जाऊन येत मग, काय अडचण नाही. एकच मिनिट. हॅलो, हा ते पवार सर यायला लागले. हा 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 तर अवघडच आहे मग. बघ काय म्हणतो ते ठेवतो. वरती कर नाही का ठेवतो. Okay, this therefore this permissible bending stress means sigma b because of this tangential force that gear tooth is going to bend. Bending moment will take place at the base. That's why bending stress will be induced. Therefore, that's why we have to study this permissible bending stress. The tooth of the gear is subjected to fluctuating bending stress as it comes in contact with the meshing tooth. The stress time diagrams for the gear teeth are illustrated in figure. See that now this is the driving gear, this is the idle gear, this is the driven gear. Now you are knowing what is the function of idle gear. Function of idle gear, first function is to bridge the gap between the driving gear and driven gear when the center distance between the two gears is more. Center distance means what? From this center to this center. Axis of the driving gear to the axis of the driven gear. The distance between the two axes is known as center distance between the two gears. This is the first function of the idle gear. Second function is to achieve desired direction of motion of the driven gear. To achieve desired direction of motion of driven gear. Now you just see, if now here one idle gear is there, driving gear rotates clockwise, idle gear is rotating anti-clockwise, therefore driven gear will rotate clockwise. Means if you will place odd number of idle gears in between driving gear and driven gear, then direction of motion of driving gear and driven gear is same. If you will place even number of idle gears between driving gear and driven gear, then direction of motion of driving and driven gear is opposite. Means that is the function of idle gear. Therefore, this is the stress time diagram for one revolution. What is the stress in case of this driving gear and driven gear? And this is for idle gear. Therefore, the following observations are made from the figure. First, the teeth of the driving and driven gears are subjected to stress in one direction only, as shown in figure B. Now you just see, this is the figure B. This is the x-axis, it is time. This is the y-axis, it is the stress. Now for one rotation, the stress is reached, that is nothing but maximum stress sigma max. Now if you will see this graph of stress, it is only on one side of this x-axis. Is it correct? These two graphs, this graph and this graph, is on one side of the x-axis, that is on the upper side. That's why it is said that here stress is in only one direction only. Therefore, it is called repeated stress. Why it is called repeated stress? This is for one revolution only. After next second revolution, same diagram is going to repeat here like this. After third revolution, same diagram is going to repeat like this. Therefore, that's why it is known as repeated stress. That's why it is known as repeated stress. Therefore, this sigma mean or mean stress is nothing but sigma max divided by 2, and sigma A, that is the axial stress or stress amplitude, is also sigma max divided by 2, where sigma max is equal to maximum bending stress, sigma m mean stress, and sigma A stress amplitude. Therefore, now this is the stress time diagram for idle gear. Stress time diagram for idle gear. What you are understanding from this? In case of idle gear, these values of stress are not repeated stress. For one revolution, values of stress are positive because they are on upper side of x-axis. Is it correct? And for another revolution, values of stress are negative because they are to the downward side of the x-axis. And you are knowing that if that point lies in the axis system, where that point lies positive, where positive values there, where negative values there. That basic things you are knowing. Therefore, the teeth of the idler gear or planetary pinion are subjected to stress in both directions. This is positive as well as negative. As shown in figure C, it is called reversed stress. It is called reversed stress. For this type of stress distribution, sigma mean is equal to 0 and sigma A is equal to sigma max. Why sigma mean is equal to 0? Can you tell me? Because these are reversed stress. Same values of suppose 100 Newton per mm square, it will act on positive side. Same value of stress is going to repeat to the downward side. That is minus 100 Newton per mm square. And sigma mean म्हणजे काय असतो? Maximum plus minimum divided by 2. Maximum stress काय आहे? 100. Minimum stress काय आहे? 100 divided by 2. And 100 plus minus 100 divided by 2 म्हणजे काय ना? समजलं का? सिग्मा एम शून्य कसा आला ते? आणि सिग्मा मॅक्स काय आहे? सिग्मा मॅक्स इकडे 100 आहे आणि इकडे मायनस 100 आहे. मग दोघांची हे काय होणार? फ्लक्च्युएशन झाले ना. मग दोघांचा डिफरन्स घ्यावा लागणार ना आपल्याला. म्हणजे काय होणार? तुमच्या लक्षात आलं का सगळ्यांच्या? This idle gear is subjected to fluctuating stress. Fluctuating means what? What is meant by fluctuation? Fluctuation म्हणजे difference between maximum and minimum. Fluctuation शब्दाचा अर्थ काय? डिफरन्स म्हणजे वजाबाकी मराठीत. समजलं का? मग मॅक्झिमम स्ट्रेस 100 आहे, मिनिमम दुसऱ्या साईडचा मॅक्झिमम स्ट्रेस मायनस 100 आहे. मग त्यांची वजाबाकी काय येणार? 100 मायनस 100 मायनस 100 डिवायडेड बाय 2 100. बरोबर आहे का? मग सिग्मा ए इज इक्वल सिग्मा मॅक्स. लक्षात आलं का तुमच्या? Therefore, for idle gear, sigma A is equal to sigma max. And mean stress कसा असतो? मॅक्झिमम प्लस मिनिमम डिवायडेड बाय 2. मीनचा फॉर्म्युला काय? मॅक्झिमम प्लस मिनिमम डिवायडेड बाय 2. लक्षात आलं ना? आणि फ्लक्च्युएशनचा फॉर्म्युला काय? मॅक्झिमम मायनस मिनिमम डिवायडेड बाय 2. लक्षात ठेवा. Therefore, since the teeth are subjected to fluctuating stresses, endurance limit stress SE is the criterion of design. Therefore, the maximum bending stress is equal to the endurance limit stress of the gear tooth. The endurance limit stress of the gear tooth depends upon the following factors. First, surface finish of the gear tooth. Second, size of the gear tooth. Third, reliability used in design. Fourth, stress concentration in the gear tooth. Fifth, gears rotating in one direction or both directions. And sixth, gears tooth subjected to stress in one direction or both directions. Therefore, endurance limit stress, that is SE, of the gear depends on these 6 factors. I think you understood it. Therefore, in practice, it is difficult to get the above mentioned data for each and every case of gear design. Therefore, Earl Buckingham has suggested that the endurance limit stress of gear tooth is approximately 1/3 of the ultimate tensile strength of the material. Therefore, in this chapter, we will use this approximate value. Therefore, sigma b, that is permissible bending stress, which is equal to permissible endurance limit or endurance strength, is equal to SUT divided by 3, where SUT is nothing but ultimate tensile strength. In case of bronze gears, the endurance limit stress is taken as 40% of the ultimate tensile strength. Therefore, if in the problem it is given that material is steel, at that time you have to take sigma b is equal to SUT divided by 3. And if they have provided that material of both the gears is bronze gears, then sigma b is equal to 0.4 of SUT. लक्षात आलं का? You have to write down simultaneously whenever I am explaining. I am not going to provide you separate time, because then double time will be lost. Is it correct? I will explain also, and if I provide on a separate time for you writing, at that time double time is in if in 1 hour whatever I want to take, that will take 2 hours. Therefore, you write down permissible bending stress sigma b is equal to SUT divided by 3. Write down permissible bending stress sigma b is equal to SUT divided by 3. Okay, I think you have written. Then next is effective load on gear tooth. Next point is effective load on gear tooth. Therefore, to determine the tangential component of the resultant force, to determine the tangential component of the resultant force between two meshing teeth, the following two equations are used. First is torque transmitted MT is equal to 16 to 10 raised to 6 into kilowatt, means power in kilowatt, divided by 2 pi n. This formula you are knowing. This is not new formula. This is the old formula. And this tangential load or tangential force PT is equal to 2mt divided by D. Tangential force or tangential load PT is equal to 2mt divided by D. Therefore, the value of the tangential component therefore depends on rated power and rated speed. Why rated power and rated speed? Because what is the formula of tangential force? PT is equal to 2mt divided by D. And if you will substitute value of mt means torque transmitted here from this equation. Therefore, PT will depend upon power transmitted and rated speed. Is it correct? Therefore, in practical applications, the torque developed by the source of power varies during the work cycle. Torque is going to vary. In practical applications, The torque developed by the source of power varies during the work cycle. Therefore, similarly, the torque required by the driven machine also varies. The two sides are balanced by means of a flywheel. The two sides are balanced by means of a flywheel. Now, whether you are knowing what is the flywheel concept you have studied, I think. Huh? कधी IC शिकला का तुम्ही flywheel, or whether you are knowing flywheel or not? Flywheel means what is the function of flywheel? You are knowing. In case of IC engine, power is developed in only one stroke, that is power stroke or expansion stroke, that is stroke number 3, and negative work has been done or negative power is developed in other 3 strokes, that is suction, compression and exhaust, and positive power or positive work is developed only during power stroke or expansion stroke. Therefore, in that power stroke or expansion stroke, what is that third stroke is there? Whatever power developed or work is done by the engine, that is more than the requirement. That is, म्हणजे तुम्हाला पाहिजे असती टॉर्क किंवा वर्क तुम्हाला पाहिजे असतं 100 न्यूटन मीटर, पण टॉर्क डेव्हलप होतो 200 ते 300 न्यूटन मीटर. समजा 200 न्यूटन मीटर डेव्हलप होतं आपण समजू आपण, मग एक्सिस किती झालं 100. म्हणजे 100 न्यूटन मीटर जो टॉर्क आहे तो टॉर्क ह्या बाकीच्या 3 स्ट्रोक चालवण्यासाठी वापरला जातो. लक्षात आलं का? सक्शन, कॉम्प्रेशन आणि एक्झॉस्ट हे बाकीचे 3 स्ट्रोक चालवण्यासाठी जो एक्सिस टॉर्क आहे तो वापरला जातो. किंवा जे टॉर्क म्हणजेच वर्क. लक्षात ठेवा, टॉर्क इज नथिंग बट वर्क. युनिट ऑफ टॉर्क अँड वर्क इज सेम, न्यूटन मीटर. Therefore, in gear design, the maximum force due to maximum torque is the criterion. Maximum force due to maximum torque is the criterion. This is accounted by means of a service factor. The service factor CS is defined as CS is equal to maximum torque divided by rated torque. Write down this formula. At least you write down the formulas. At least you write down the formulas. CS is equal to maximum torque divided by rated torque. That is, CS is equal to MT max divided by MT, which is equal to PT max divided by PT. Where PT is the tangential force due to rated torque MT. Where PT is the tangential force due to rated torque MT. Therefore, rearranging the terms, PT max is equal to what? CS into PT. PT max is equal to CS into PT. CS means service factor. Therefore, for electric motors, CS is equal to starting torque divided by rated torque. Write down this formula. For electric motors, service factor CS is equal to starting torque divided by rated torque. I think you have written. You are writing or not? Why you are not writing? Whether you have written this? Huh? का? And now what is the problem? Why you are wasting your double time? Here you are sitting idle, and again you are going to use that your free time for writing this. Means you are wasting time. That means you are having 48 hours in a day. We are having 24 hours, you are having 48 hours. And that whatever you are telling the sun, you are making phone call to the sun. Sun means SUN. That please run slow so that I will get 48 hours. Whether you are having phone number of sun, if you are having, give that phone number to me so that I will also make phone call to him. Therefore, the values of the service factor are given in this table. The examples of driving and driven machines with different working characteristics are given in table 5 and 6. Therefore, this is table number 4, service factor for speed reduction gearboxes. In that first column is, this is the table. Don't write that service factor is provided in the problem. Just I will read it for your understanding. Working characteristics of driving machine and working characteristics of driven machine. In that driven machine, again 3 columns are there. Uniform, moderate shock, heavy shock. Now for uniform characteristic, values are 1, 1.25, 1.75. Light shock 1.25, 1.5, 2.0. Then medium shock 1.5, 1.75, 2.25. Means these are the values of the service factor for the speed reduction gearboxes. Now table 5 indicates examples of driving machines with different working characteristics. It is not there, it will not be asked, but you must know the thing. That's why I am telling. Therefore, characteristic of operation. Where is uniform characteristics you are observing? When driving machines are electric motor, steam turbine, and gas turbine. There you are having uniform characteristic. Uniform characteristic म्हणजे काय? X is directly proportional to Y. समजलं का? म्हणजे एक गोष्ट वाढली तर दुसरी गोष्ट पण वाढणार. त्याला म्हणतात युनिफॉर्मिटी. एक गोष्ट कमी झाली तर दुसरी गोष्ट पण कमी होणार. समजा एक गोष्ट वाढली दुसरी गोष्ट कमी झाली, that is not uniformity. That is reciprocal or reverse. You have to understand the things. Then light shock. Where light shock characteristics are existing? Multi-cylinder internal combustion engine. And medium shock characteristic, single cylinder internal combustion engine. समजलं का? Table 5. Now table 6. Examples of driven machines. अगोदर कुठला होता? Driving machines. Now these examples of driven machines with different working characteristics. Characteristic of operation and driven machines. First is uniform characteristic, generator, belt conveyor, platform conveyor, light elevator, electric hoist, feed gears of machine tools, ventilators, turbo blower, mixer for constant density material. Then medium shock, main drive to machine tool, heavy elevator, turning gears of train, mine ventilator, mixer for variable density material, multi-cylinder piston pump, then feed pump. Then heavy shock, press, shear, rubber, dough mill, rolling mill drive, power shovel, heavy centrifuge, heavy feed pump, rotary drilling apparatus, briquette press, pug mill. Means this table 6 indicates examples of driven machines. Therefore, when gears rotate at very low speed, almost at zero velocity, the transmitted load, that is PT, can be considered to be the actual force present between two machine teeth. However, in most of the cases, the gears rotate at an appreciable speed, and it becomes necessary to consider the dynamic force resulting from the impact between the mating teeth. Why it is dynamic force word is there? Dynamic म्हणजे काय? In motion. Dynamic शब्दाचा अर्थ काय? मोशन. मोशन मध्ये कुठली गोष्ट असते त्याला डायनामिक म्हणतात, लक्षात ठेवा. स्टॅटिक म्हणजे स्टेशनरी, डायनामिक म्हणजे इन मोशन. Therefore, since gears are rotated or when two gears are in contact, they are rotating or their peripheral velocity is more. Peripheral velocity म्हणजेच tangential velocity. लक्षात ठेवा, म्हणजेच circumferential velocity. I am taking synonyms also. You have to understand how I am speaking or which words I am speaking. Therefore, that velocity, that tangential velocity or circumferential velocity or peripheral velocity, that is considerably more when two gears are rotating. Yesterday I have shown you the animation. Therefore, that's why we have to consider dynamic force between the two mating teeth, because when two gears are they are coming in contact with each other, one gear tooth is going to exert force on another gear tooth. That is impact force is there, like this. Therefore, the dynamic force is induced due to the following factors. Dynamic force कशामुळे तयार होतो? The following factors मुळे. Inaccuracies of the tooth profile. Inaccuracies of the tooth profile means what? What is profile of the tooth? Profile of the tooth is nothing but it is the curve formed by face and tank of the tooth. Gears are whatever that surface of the gear is there, face and flank. Therefore, that is known as profile of the gear tooth. If certain inaccuracies is there in the profile, at that time this dynamic force is going to exist. Next is errors in tooth spacing. Tooth space म्हणजे काय? The space between the two gear teeth is known as tooth space. Toothpaste नाही बरं का? आता म्हणतात Colgate toothpaste. Tooth space. Next is misalignment between bearings. Then fourth is elasticity of parts. And fifth is inertia of rotating disc. Therefore, these 5 causes are there because of which dynamic force is going to exist. Therefore, there are 2 methods to account for the dynamic load. First is the approximate estimation by the velocity factor in the preliminary stages of gear design, and second is precise calculation by Buckingham's equation in the final stages of gear design. Therefore, we can calculate dynamic load by using these 2 methods. Now, in our syllabus, that Squat's equation is there. MF squat. That we are going to study. I think you have written this. No, not necessary, but you must know the things, because during oral examination, I don't know whether oral exam is there or not. External oral for design 2. If it is there, at that time these questions will be asked to you. What are the causes of dynamic force between when the two gear teeth are in contact with each other? What are the causes? Therefore, it is difficult to calculate the exact magnitude of dynamic load or dynamic force in the preliminary stages of gear design. To overcome this difficulty, a velocity factor CV. You write down these three equations. CV developed by Barth is used. The values of the velocity factor is as follows. You write down this statement also. Statement also you write down. First, for ordinary and commercially cut gears made with form cutters and with peripheral velocity v is less than 10 meter per second, CV is equal to 3 divided by 3 plus v. Second, for accurately hopped and generated gears with v is less than 20 meter per second, CV is equal to 6 divided by 6 plus v. And third, for precision gears with shaving, grinding and lapping operations with v is greater than 20 meter per second, CV is equal to 5.6 divided by 5.6 plus root v, where v is equal to pitch line velocity. Another name for this circumferential, tangential or peripheral velocity is pitch line velocity. And how to calculate v? V is equal to r omega. V is equal to r omega. I think you have written. Okay, you write down the pitch line velocity is given by v is equal to pi d n divided by 60,000. Pi d is 60,000, where small d is equal to pitch circle diameter in mm. Since d is in mm, here in the denominator, that value is 60,000. n is equal to speed in rpm. Therefore, the effective load between two meshing teeth, is given by P effective is equal to CSPT upon CV. CSPT upon CV. The velocity factor is an empirical relationship developed by past experience. This method of calculating dynamic load has the following advantages. First is, it is much easier to calculate the velocity factor and design gears. Second, velocity factors have sanctions of the American Gear Manufacturing Association, that is AGMA, and they were used in the past for many years and given satisfactory results. You write down only formulas only, yeah? Don't write this theory. Write down only formulas. I think you have written. Therefore, the disadvantages of the velocity factor method are as follows. First is the dynamic load depends upon a number of factors such as the mass of gears, mass connected to the gear shaft, and properties of the gear material. Like, what are the properties of the gear material? All physical properties: melting point, density, mass. I am not seeing there. Physical properties you must know. What is its ultimate tensile strength? What is its Young's modulus? These are the physical properties of the material. See that whatever I told, same things are here. Physical, the dynamic load depends upon a number of factors such as the mass of the gears, mass connected to the gear shaft, and properties of the gear material like modulus of elasticity. Young's modulus, you are knowing stress upon strain is equal to Young's modulus. A gear tooth of a material with low modulus of elasticity will deflect more than the gear tooth material with higher modulus of elasticity, and other things being equal, will absorb the energy of impact and reduce the dynamic load. Velocity factor method neglects these factors. It assumes that dynamic load depends only upon pitch line velocity. Means this velocity factor, what it is assuming? Dynamic load depends upon pitch line velocity only, that is V only. But in earlier case, what we have studied? Dynamic load depends upon these factors. You are understanding or not? What is going on? Therefore, use of velocity factor is restricted to a limited range of pitch line velocities. It is not possible to extrapolate the values. Extrapolate म्हणजे काय? What is extrapolation? Use of velocity factor is restricted to a limited range of pitch line velocity. Limited range of pitch line velocity म्हणजे काय? काहीतरी pitch line velocity ची रेंज असतात ना, 20 मीटर पर सेकंद पर्यंत तुम्ही velocity factor काढू शकता, किंवा 40 मीटर पर सेकंद पर्यंत velocity factor काढू शकता. त्याच्या पुढे गेलं तर जो velocity factor CV निघतो तो चुकीचा असू शकतो. लक्षात आलं का? लिमिटेड रेंज ऑफ पिच लाइन वेलोसिटी. रेंज म्हणजे समजलं तुम्हाला? रेंज, व्हॉट इज डिफरन्स बिटवीन रेंज, व्हॉट इज मीनिंग ऑफ रेंज? रेंज म्हणजे डिफरन्स बिटवीन मॅक्सिमम आणि मिनिमम. मॅक्सिमम मायनस मिनिमम म्हणजे रेंज, लक्षात ठेवा. Therefore, in the final stages of gear design, you write down this statement and this formula also. In the final stages of gear design, when gear dimensions are known, errors specified, errors on pinion, errors on gear, and the quality of gears determined, the dynamic load is calculated by equations derived by Earl Buckingham. The effective load is given by P effective is equal to CSPT plus PD. P effective is equal to CSPT plus PD, where PD is the dynamic load or additional load due to dynamic conditions between two meshing teeth. Write down this. Okay. Now see that. Write down next point. Effective load by Spott's equation. Effective load by Spott's equation. Into bracket precise estimation. Therefore, effective load by Spott's equation. Write down this equation. P effective is equal to P effective is equal to CSPT plus PD. बोलना correct. CSPT plus PD. Therefore, depending upon the materials of the pinion and gear, there are three equations for the dynamic load. Now, these equations we are going to use while solving the problems. Remember, therefore, for steel pinion and steel gear, PD is equal to ENPZP into B R1 R2 divided by 2530 square root of R1 square plus R2 square, where R1 and R2 are pitch circle radius of the pinion and gear respectively. Pitch circle radius of the pinion and gear. Pitch circle radius म्हणजे काय? Pitch circle diameter divided by 2. What is the formula of radius? Diameter divided by 2 म्हणजे radius लक्षात ठेवा. काय म्हणून म्हणतात? Radius is equal to 2D. Basic things are there. These are not new things. Next, now here E म्हणजे काय? What is E means total error. NP means speed of pinion. ZP means number of teeth on pinion. In this subject, we are going to use Z as the letter for number of teeth. Remember, therefore, for cast iron pinion and cast iron gear, PD is equal to ENPZP B R1 R2 divided by 3785 into square root of R1 square plus R2 square. Then for steel pinion and cast iron gear, PD is equal to ENPZP B R1 R2 divided by 3260 into square root of R1 square plus 0.92 R2 square, where R1 and R2 are the, I have written here, pitch circle radius of pinion and gear respectively. Pitch circle radius of pinion and gear respectively. Okay, whether you have written all the three equations. Now this time your exam will be offline. Therefore, those students who are online, please write down these equations. Examination will be offline. Now this COVID-19 is over. Don't think that you will get passed easily. Like that objective examination is there. You are knowing that if you are not going to attend lectures, still you are going to pass during online examination. Now, but this time onwards, offline exam will be there. You have to write down, then and then it is possible for you to write in examination. Otherwise, you will forget what is meant by pen, what is meant by paper. Therefore, the incremental dynamic load PD calculated by Buckingham equation is far more than the corresponding load calculated by the velocity factor method. Means whatever these equations are there, whatever we have calculated this dynamic load, this load is more than the load calculated by using the velocity factor method. Earlier we have seen. Very often it is 3 to 4 times the load PT. Means dynamic load is greater than 3 to 4 times of tangential load. PT means tangential load due to power transmission. Therefore, it has been observed that in most of the practical cases, the actual dynamic load is less than that of the calculated values by Buckingham equation. This is because the equation is mainly applicable to large gears with connected masses that rotate at moderate speeds. Means what this statement says? It has been observed that in most of the practical cases, the actual dynamic load is less than that of the calculated values of by Buckingham equation, because the equation is mainly applicable to large gears with connected masses that rotate at moderate speeds. Connected masses means what? These gears may be connected to pulley. Pulleys are also there on the shaft. Pulley or flywheel. Therefore, the actual dynamic load is less in the following cases. Which are the cases? Small gears transmitting low power. Second, high speed light load gears. Third, small gears on small shaft. Fourth, gear shafts up to 50 mm diameter. And fifth, small gears transmitting less than 15 kilowatt of power. Gears on small diameter shaft easily twist through an angle equivalent to the effective tooth error, and the dynamic load is reduced. Therefore, write down this formula. The error is given by E is equal to EP plus EG. Error is given by E is equal to EP plus EG, where EP is equal to error for pinion, EG is equal to error for gear. Write down EP is equal to error for pinion, EG is equal to error for gear. The error depends upon the quality of the gear and the method of manufacture. The error depends upon the quality of the gear and method of manufacture. There are 12 different grades from grade 1 to grade 12 in decreasing order of precision. The expected error on the gear tooth is considered to be equal to tolerance. The expected error on the gear tooth is considered to be equal to the tolerance. That tolerance is in microns. लक्षात ठेवा. Tolerance is in microns because when the two gear teeth are going to come in contact with each other, that small clearance is to be provided. Clearance नाही provide केला तर काय होईल? What will happen if you will not provide clearance? This gear teeth is going to jam. They will not rotate. Okay. Okay, the error depends on the quality of the gears, and there are 12 different grades, grade 1 to grade 12. Now, how these grades are there? I think you have studied it in machine drawing. Whether you have studied in machine drawing that 1 triangle, 2 triangle, surface finish, 3 triangle, 4 triangle. Sheet काढला का तुम्ही? ऑनलाइन मध्ये ऑनलाइन शीट काढला. ऑनलाइन शीट काढला असणार बरोबर ना. शीट तुम्ही ऑनलाइन घेतली असणार पांढरे पेंट मध्ये ती पण आणि पेंट मध्ये तुम्ही मशीन ड्रॉइंग चे चित्र काढले असणार बरोबर ना. That is online. Therefore, oh sorry, the tolerances for adjacent pitch error key are given in table 7. These tolerances are calculated by using the following equation. Write down this equation. Phi is equal to m plus 0.25 into root d, where phi is equal to tolerance factor, m is equal to module in mm, and d is equal to pitch circle diameter in mm. Write down this equation. Phi is equal to m plus 0.25 into root d. Phi is equal to tolerance factor. M is equal to module in mm. D is equal to pitch circle diameter in mm. And these are the grades. These are the grades depending upon the type. Don't write down these grades. Or if you want to write, you can write down. These are the grades, tolerances on adjacent pitch. Now these grades are depending upon the method of manufacturing. These grades are depends upon the method of manufacturing. What are different manufacturing methods? Casting, welding, rolling, forging. These are the manufacturing methods. So त्याच्यामध्ये पण अजून super finishing methods आहेत. What are the super finishing methods? Lapping, honing. झाले का तुम्हाला ते? Honing, lapping, buffing. These are the super finishing methods. And this advanced machining processes we have seen. Non-traditional machining processes, EDM, electric discharge machining, ultrasonic machining, electrochemical machining, wire electrical discharge machining. These are known as non-traditional methods. Traditional methods कुठल्या? Traditional methods means machining on lathe machine, milling machine, drilling machine, planing machine, shaping machine, sorting machine. These are traditional machines or traditional machine methods. Lakshat ठेवा. Therefore, these grades sort depends on the type of manufacturing. 1 to 12 grades are there. Grade 8, 16 plus 1.425D. Grade 9, 22 plus 1.85. Grade 11, 45 plus 3.555, where 5 is nothing but this value. M plus 0.25D. Value of M is provided to you. Value of pitch circle diameter is also known to you. Therefore, the method of manufacture for gears depends upon the grade of the gears. Gears of grade 11 and 12 are manufactured by casting. Gears of grade 8 and grade 9 require rough and fine hobbing. Gears of grade 6 are obtained by hobbing and rough grinding. And while gear 4 requires shaving and finish grinding. Grinding also super finishing operation. Huh? Grinding you have studied. Grinding wheels that you have not studied. Grinding chapter maybe you have studied in machine tool subject. Material is removed in terms of microns. तुम्ही ऑनलाइन वर लेथ मशीन शिकलाय त्याच्यामुळे तुम्हाला लेथ मशीन ऑनलाइन चालवायची क्लास मध्ये त्याच्यावर तुम्हाला काय माहितीच नसणार. Now next point is wear strength of gear tooth. So write down this point. Don't write down theory, write down only formulas. Wear strength of gear tooth. Earlier we have seen beam strength. Next, now this is wear strength. What is meant by wear? Already I have told this concept to you. Wear means what? When time will elapse, at that time wear and tear takes place. Suppose we are wearing shoes and chappal. जेव्हा आपण नवीन शूज आणि नवीन चप्पल घेतो तेव्हा त्याची पायावरची आपली ग्रीप कशी असते? टाईट असते, बरोबर का? किंवा ग्राउंड वरची ग्रीप पण कशी असते शूजची? टाईट असते. म्हणजे तो शूज जमिनीला पकडतो लवकर. पण जसं तुम्ही शूज 1 वर्ष झाला 2 वर्ष झाला त्यास काय होतं? खालचा सरफेस वियर होतो किंवा तो शूज जेव्हा तुम्ही सारखा वापरता तेव्हा त्याची पायावरची ग्रीप पण काय होती? कमी होती. म्हणजे वियर अँड टियर होतं. ती चप्पल पण बघा आपण इझिली पाय घालतो, इझिली पाय बाहेर घालतो. म्हणजे आपल्याला समजत पण नाही की आपण चप्पल घातली का नाही. नवीन चप्पल घालताना आपण पाय कसा करतो? असा टकवून पायात घालतो, बरोबर ना? Therefore, whenever anything is new, at that time pressure is uniform. At that time pressure is uniform. Therefore, whenever any new thing is there, you have to consider uniform pressure theory. And when you are going to use that thing continuously or for 1 year, 2 year, 3 year, 5 year, up to 10, 15 years, at that time that wear and tear takes place, and that's why at that time you have to consider uniform wear theory. Uniform wear theory. Therefore, this is not that is nothing but wear strength of gear tooth. Wear strength म्हणजे काय? You are not replacing the gears every after 1 month or 2 months. 2-wheeler मधला gearbox तुम्ही 1-2 महिन्यांनी चेंज करता का? You are using that gearbox for 10 to 15 years. That means what? that you have to consider wear strength of gear tooth. While designing the gear, you have to consider wear strength so that that gear will last longer or anything is going to last longer. Already I have told you examples of the shoes: Puma, Adidas, then Nike, Reebok. Yes, whatever Woodland, Red Chip. These companies are there. If you purchase that shoes, their cost is so much, but that shoes are lasting for 5 to 6 years. And if you purchase that Sparks and whatever that local companies are there, within 6 months, that shoes is going to worn out or that crack is going to develop. Means low cost, low quality. High cost, high quality. Though you can't compare the quality. You can't compare quality and cost. This is the example of considering wear strength. Therefore, when contact stresses between two meshing teeth exceed the surface endurance strength of the material, pitting is a surface fatigue failure. Pitting म्हणजे काय? Small amount of material removed from the surface. Small amount of material removed from the surface. तुम्ही नदीवरती कधी गेलाय का? दगड असतात बघा दगड. तो दगड अगोदर एकदम चकचकीत असतो. समजा तुम्ही एखादा दगड बघितला आणि तोच दगड तुम्ही बघायला 1 वर्षांनी गेला तर काय होणार? तर दगडावरती छोटे छोटे होल असतात ना. That is nothing but pitting failure. Because of that water, continuous flow of water over that stone. And that is because of cavitation pressure. Cavitation phenomenon you have studied. Whenever liquid is coming there, for cavitation phenomenon is there. Due to cavitation phenomenon, wear and tear of the stone takes place. And the wear and tear of stone takes place केल्यामुळे वाळू तयार होते. लक्षात ठेवा. वाळू कशामुळे तयार होती? जे मोठमोठे स्टोन्स असतात त्यांचे स्मॉल पार्टिकल पाण्यामुळे खाली पडतात, तयार होतात. ती वाळू असते. लक्षात ठेवा. आणि ते मात्र वाळू पहिला आपोआप तयार होती, नदी घेऊन येते काय. तसे वाळू कधी आपोआप तयार होत नाही. बिकॉज ऑफ दॅट कंटिन्युअस force of the water, cavitation pressure, there is wear and tear of the stones, and because of that sand is created. And therefore that pitting is the surface fatigue failure characterized by small pits on the surface of the gear tooth. In order to avoid this type of failure, the proportions of the gear tooth and the surface properties such as surface hardness should be selected in such a way that the wear strength of the gear tooth is more than the effective load between the meshing teeth. Therefore, to avoid the wear, what should be the condition? The surface hardness of the gear tooth should be more. Surface hardness आपण कशाने increase करतो? Hardening processes. Surface hardening processes, that is nothing but carburizing, nitriding, case carburizing, cyaniding, flame hardening, induction hardening. These are the methods of heat treatment to increase the surface hardness. Therefore, and because of this surface hardness, if surface hardness means like this, if hardness of this bench will increase or surface will increase, what will happen? It is going to resist wear and tear. It is going to resist wear and tear. Therefore, the analysis of wear strength was done by Earl Buckingham in his paper, The Relation of Load to Wear of Gear Teeth, which was submitted before the American Gear Manufacturing Association (AGMA) in 1926. Buckingham's equation gives the wear strength of the gear tooth. Therefore, Buckingham's equation is based on Hurd's theory of contact stress. When two cylinders, now how these two cylinders they have considered? They have considered two gears as two cylinders. They have considered two gears as the two cylinders. Means two gears are in contact with each other. They have considered that these gears are replaced by cylinders and two cylinders are in contact with each other. Therefore, this radial force P will act. This D1 pitch circle diameter of first gear, D2 pitch circle diameter of another gear, or D1 pitch circle diameter of pinion, D2 pitch circle diameter of gear wheel. Therefore, the contact stress is given by sigma C is equal to 2P divided by pi BL. 2P divided by pi BL, where B is equal to 2P into bracket 1 minus mu square into bracket 1 upon E1 plus 1 upon E2 divided by pi into L into bracket 1 upon D1 plus 1 upon D2 bracket raised to 1 by 2. That is the value of B, where sigma C is equal to maximum value of compressive stress in Newton per mm square. P is equal to force pressing the two cylinders together in Newton. B is equal to half width of deformation, that is in mm. L, this is L, this is not 1. This is L. Axial length of the cylinder in mm. D1, D2 diameters of the two cylinders in mm. E1, E2 modulus of elasticity of two cylinder material Newton per mm square, and mu is equal to Poisson's ratio. Mu is equal to Poisson's ratio. I think you are written. Okay, whether it's completed. Okay, I think you are completed. Okay. Now, when the two cylinders are pressed because of this compressive force P, what will happen? At the point of contact, these two cylinders, what will happen if these two cylinders are pressed like this? एक फ्लॅट पोर्शन तयार होणार ना. बरोबर का? तुम्ही बघा की दोन मातीचे गोळे घ्या, सिलेंडर बनवते मातीचे आणि ते एकमेकावर असे फक्त ठेवा आणि परत काढा, काय होणार? कॉन्टॅक्ट पोर्शन काय होणार? एक फ्लॅट सरफेस तयार होणार, बरोबर आहे का? And that flat surface is nothing but like this. There you will get this elliptical stress distribution. This stress distribution is what? Elliptical stress distribution. Therefore, due to deformation under the action of load P, तो फ्लॅट पोर्शन म्हणजे काय? रेक्टेंग्युलर सरफेस तयार होणार ना तो. इमॅजिन करा जरा, इमॅजिन द थिंग्स. A rectangular surface of width 2b and length L is formed between the two cylinders. The elliptical stress distribution across the width 2b is shown in figure B and C. This is the elliptical stress distribution. Its width is 2b and length is L. Therefore, substituting equation B in equation A and squaring both sides, we are getting the equation sigma c square is equal to 1 divided by pi into bracket 1 minus mu square into p divided by L into bracket 1 upon r1 square plus 1 upon r2, oh sorry, 1 upon r1 plus 1 upon r2 divided by 1 upon e1 plus 1 upon e2, where r1 and r2 are the radii of the two cylinders. Substituting where r1 and r2 of the radii of the two cylinders, substituting mu is equal to 0.3, we are getting sigma c square is equal to 0.35 p into L into bracket 1 upon r1 plus 1 upon r2 divided by 1 upon e1 plus 1 upon e2. Therefore, if you want to write, you can write down. When this equation gets displayed, at that time only you have to start writing, or you can start writing the things. Don't wait that when I will tell, then you have to write. Okay, I think you have written. The above equation of the contact stress is based on the following assumptions. First, the cylinders are made of isotropic materials. Second, the elastic limit of the material is not exceeded. Third, the dimensions R1, R2 are very large when compared to the width 2b of the deformation. Therefore, figure shows the contact between the two meshing teeth at the pitch point. The radii R1 dash and R2 dash are to be replaced by the radii of curvature at the pitch point. Therefore, R1 dash is equal to dp sin alpha divided by 2 and R2 dash is equal to dg sin alpha divided by 2. See that these are the R1 and dash and R2 dash. These are the radius. R1 dash is here, R2 dash is here. Therefore, there are two reasons for taking the radio of curvature at the pitch point. First, the wear of the gear tooth generally occurs at or near the pitch point or pitch line. Pitch line means that horizontal line that is known as pitch line. When the two gears, if these two gears are there, therefore this horizontal line is known as pitch line. And this line is also known as common tangent. This line is also known as common tangent. When only one pair of teeth carries the entire load, the contact occurs at the pitch point. This is the pitch point P. Remember, this is the pitch point P, common point of contact between the two gears. When only one pair of teeth carries the entire load, the contact occurs at the pitch point. When the contact takes place at the top or at the bottom of the tooth profile, usually two pairs of meshing teeth share the load. The dynamic load is imposed on the gear tooth near the pitch line area. This is the pitch line area. Near the pitch line area means here itself, like this. Between these two portions, these two lines only, this dynamic load will get imposed. The dynamic load is imposed on the gear tooth near the pitch line area. Therefore, it is more reasonable to select the radius of curvature at the pitch point only. Why was selected radius at the pitch point? Because dynamic load is going to exist near to the pitch point only. Dynamic load is not at this point. Always remember, when dynamic load will exist, when the gear teeth will come in contact with each other, at that time only dynamic load will exist. When the gear teeth are not in contact with each other, there is no dynamic load. Therefore, 1 upon R1 dash plus 1 upon R2 dash is equal to 2 divided by sin alpha into bracket 1 upon dp plus 1 upon dg. Therefore, a ratio factor Q is defined as Q is equal to 2zg divided by zg plus zp. Therefore, substituting dp is equal to mzp and dg is equal to mzg in above equation, we are getting Q is equal to 2dg divided by dg plus dp. Therefore, 1 upon dp plus 1 upon dg is equal to dp plus dg divided by dp dg is equal to 2 divided by q dp. 2 divided by q dp. Write down. I will wait for 1 minute. See that you must do the writing practice. Otherwise, it will be difficult for you at the time of examination. Okay, I think you have written this. Okay, therefore, from equation E and G, 1 upon R1 dash plus 1 upon R2 dash is equal to 4 divided by Q dp sin alpha, equation H. The force acting along the pitch line is Pn. The force acting along the pitch line is Pn. Therefore, P is equal to Pn, which is equal to Pt divided by cos alpha. This equation already was studied. The axial length of the gears is the phase width B, that is L is equal to B. Equation K, therefore substituting equations H, J and K in equation D, we are getting the equation sigma C square is equal to 1.4 Pt divided by BQ dp dash sin alpha cos alpha into bracket 1 upon E1 plus 1 upon E2, equation L. I will wait for 1 minute, write down. What? 1.4 Pt divided by BQ dp dash sin alpha cos alpha into bracket 1 upon E1 plus 1 upon E2. Okay. Over. Therefore, a load stress factor K is defined as K is equal to sigma C square sin alpha cos alpha into bracket 1 upon E1 plus 1 upon E2 divided by 1.4. Therefore, substituting the above equation in equation L, we are getting Pt is equal to BQ dpk. We are getting Pt is equal to BQ dpk. Therefore, this is known as weir strength equation. Remember, this equation is known as weir strength equation. Now, what we are going to replace? We are going to replace this Pt by SW. SW means weir strength. Therefore, this equation gives a relationship between the tangential force Pt and the corresponding contact stress sigma C. This is sigma C or K. When the tangential force is increased, the contact stress also increases. Pitting occurs when the contact stress reaches the magnitude of the surface endurance strength. The corresponding value of Pt is called weir strength. The corresponding value of Pt is called weir strength. When pitting occurs, when the contact stress reaches the magnitude of surface endurance strength, Pt is equal to BQ dpk. Therefore, what we have to do? We have to replace Pt by SW. Therefore, the weir strength is the maximum value of the tangential force that the gear tooth can transmit without pitting failure. What is meant by weir strength? The maximum value of tangential force the gear tooth can transmit without pitting failure. Therefore, replacing Pt by SW, we are getting SW, that is weir strength is equal to BQ dpk, where SW is equal to wear strength of the gear tooth. Yes, C is nothing but surface endurance strength of the gear tooth material Newton per mm square. Above equation is known as Buckingham's equation for wear. This equation is known as Buckingham's equation for the wear. Now the earlier we have defined ratio factor. That ratio factor Q is for external gears. Now this ratio factor is for internal gears. Internal gear means what? See that these two gears are external gears. These two gears are external gears. These two gears are internal gears. This is internal. When two gears are in contact internally with each other. These two gears are external gears. These two gears are external gears. Therefore, for an internal gear, Q is equal to 2 ZG divided by ZG minus ZP. For external gears, what is the value of Q? Q is equal to 2 ZG divided by ZG plus ZP. This is for external gear. This value is for internal gear. Therefore, the expression for the load stress factor K can be simplified when both the gears are made of steel and 20-degree pressure angle. In this case, E1 is equal to E2 is equal to 2.06 into 10 raised to 5 Newton per mm square. Alpha is equal to 20 degree. Therefore, according to G. Niemann, sigma C is equal to 0.27 BHN into kgf per mm square, or sigma C is equal to 0.27 into 9.81 into BHN. BHN is perennial hardness number, Newton per mm square. Therefore, K is equal to this formula we are knowing, sigma C square sin alpha cos alpha into bracket 1 upon E1 plus 1 upon E2 divided by 1.4. Therefore, if we substitute all these values, final value we are getting for the K is 0.16 into BHN divided by 100 bracket square, and this value we are going to use for the calculation. Directly we are going to take this value of the K for our calculation. K is equal to 0.16 BHN divided by 100 bracket square. Therefore, the above equation is applicable only when both the gears are made of steel material and 20-degree pressure angle. This above value is applicable when both the gears are made up of steel material and they are having 20-degree pressure angle. Okay, completed. Write down only this formula. K is equal to 0.16 BHN divided by 100 bracket square. Therefore, this table 8 gives the material properties for the calculation of K. In order to avoid failure of the gear tooth due to pitting, the wear strength should be more than the effective force between the machine teeth. Therefore, table 8 values of modulus of elasticity and Poisson's ratio for gear materials. First column is gear material, second column is modulus of elasticity in Newton per mm square. Third column is Poisson's ratio. Poisson's ratio you are knowing, it is the pure ratio, that's why it is having no in it. Lateral strain divided by linear strain. Therefore, for steel, modulus of elasticity is equal to 2.06 into 10 raised to 5, Poisson's ratio 0.3. Cast steel 2.02 into 10 raised to 5, 0.3. Spheroidal cast iron 1.73 into 10 raised to 5.3. Cast tin bronze 1.03 into 10 raised to 5 into and 0.3. Tin bronze 1.13 into 10 raised to 5.3. Gray cast iron 1.18 into 10 raised to 5.3. Therefore, write down these steps now one by one. Now theory is over. Hereafter we are going to study problems only. Now there will be two questions. Two types of questions will be asked on the spur gear design. First is to determine the module, and second is to determine the power transmitted. Second is to determine the power transmitted. Therefore, that how to calculate power, that is very simple. Therefore, to calculate module, write down these steps. According to these steps, we are going to find out the module. First, write down, calculate the torque transmitted, that is MT, from the power, that is kilowatt formula. Calculate the tangential load PT or force PT in terms of module M from the torque transmitted MT. That is MT is equal to PT into dP divided by 2, where dP is equal to pitch circle diameter of pinion in mm, which is equal to M into Zp. M is equal to module, Zp is equal to number of teeth on pinion. Therefore, PT is equal to 2MT divided by M into Zp. Now calculate value of SB in terms of M square. How it will come in terms of M square? M we are not knowing. M ची व्हॅल्यू माहिती आहे आपल्याला, कारण आपण काय लिहिले स्टेप्स टू कॅल्क्युलेट मॉड्यूल. Therefore, SB is equal to MD sigma B into Y. M into 10M. B ची व्हॅल्यू काय असते? इन जनरल 10 टाइम्स मॉड्यूल असते. B ची व्हॅल्यू काय असते? 10 times module. M into 10M into SUT divided by 3 into Y. Therefore, B is equal to 10M, sigma B is equal to SUT divided by 3. And Levy's form factor Y is provided to you in the problem. Therefore, value of SB you will get in terms of M square, module square. I think you are written. Write down next step. Step number 4. If Brinell hardness PHN is given, then calculate wear strength SW in terms of M square. So what is the formula of SW? SW is equal to BQ dPk, equation 3, where B is equal to 10 M, dP is equal to M into ZP, Q is equal to 2 ZG divided by ZG plus ZP, K is equal to 0.16 into BHN divided by 100 bracket square. Now compare SB and SW. Take the value which is minimum of the two for further calculations. Take the value which is minimum of 2 for further calculations. Okay, completed. Next, write down step number 6. Calculate effective load by using P effective is equal to CS PT upon CV. Equation 4, where CV is the velocity factor. Now these three different values of CV are there for ordinary and commercially cut gears. Commercially cut gears made with foam cutters and V is less than 10 meter per second. CV is equal to 3 divided by 3 plus V. For accurately hopped and generated gears with V is less than 20 meter per second, CV is equal to 6 divided by 6 plus V. Third, for precision gears with shaving, grinding and lapping operations, where V is greater than 20 meter per second, CV is equal to 5.6 divided by 5.6 plus root V, where V is the pitch line velocity in meter per second. Now what we have to do? We have to assume V is equal to 5 meter per second in the initial stage. What we have to do? We have to assume V is equal to 5 meter per second in the initial stage. Then equate P effective of equation 4 to the minimum value of SB or SW. And last step, 8th step is calculate value of module M. Calculate value of module M. These are the steps when we are going to solve the problem related to module. We have to do these steps automatically. You can find out the module. Okay, completed. Now this problem we'll study in next lecture. Now we'll stop here. Please don't leave the class. I will take your attendance. Don't leave the class.